Hey, so today I'm here to talk about evaluating limits graphically. I'm going to start things with the graph that you see in front of you. The very first thing I'm going to look at is the end behavior of this graph. So let's start by looking at the right end behavior and the left end behavior. When discussing end behavior, we're looking at what happens at the ends of the function. We're looking at what happens for the limit of the right side of the function as x goes to infinity, and the limit as f of x goes, or as x goes to negative infinity of the function. You can see here that the limit as x goes to infinity, the function f of x goes towards infinity because the function keeps increasing without end. And the limit as x goes to negative infinity for the function f of x, it's going to go towards negative infinity. Instead of looking at end behaviors, let's look at the limits of specific points. On this, let's look at the limit as x goes towards 3 for the function f of x. If we look carefully at this graph, we can see as x approaches 3, our graph appears to be approaching the value of 4. In order for a limit to exist at a specific point, such as x goes to 3, the limit must be the same as we approach that point from both the left and the right. So from the left, as x approaches 3 from the left-hand side, notice the notation. I'm using x goes to 3 with a negative sign to the top right of the x, indicating that I'm coming towards that value from the left side of it. So following my cursor, you can see that as I'm coming towards 3 from the left, I'm at 1.5, at 2, 2.5, now approaching it at 3. That limit is approaching the value of 4. Let's also look at the limit as x goes to 3 from the right-hand side. The notation uses a positive plus sign after the number 3. So I am approaching 3 from the right-hand side. So starting at a value larger than 3, looking at my cursor, I'm going to start coming down the graph towards the value of 3 from the right-hand side of it, and I can see it still lines up where f of x equals 4. The limit from the left-hand side of 3, as x goes to 3 with the negative, equals 4, is the same as the limit as I approach x to the right of 3, both of which equals 4. So the left-hand limit and the right-hand limit are both the same. So now I can say the limit as x goes towards 3 of the function f of x equals 4. The left-hand limit is the same as the right-hand limit, so the limit specifically at 3 is equal to 4. Let's look at the limit as x approaches 0. First, we have to look at the limit as x approaches 0 from the left. So following my pen, I'm going to start on the far left of 0, approximately at x equals negative 2, and you can follow my pen. As I get closer and closer to 0 from the left-hand side, I could say that the function f of x is approaching approximately 1/2. Now let's find the limit as x approaches 0 from the right-hand side. I'm coming from the right of 0 towards 0, and I'm getting, again, the same value that f of x is approaching 1/2. So now I can make the statement, the limit as x approaches 0 of f of x is equal to 1/2. This is because the left-hand limit of 1/2 is equal to the right-hand limit of 1/2. In order for a limit to exist, the left and right-hand limits must be the same. In this case, they are. Let's now look at the limit as x approaches 1, where we have a jump in the curve. First, I have to find the limit as x goes to 1 from the left-hand side, following my cursor. You can see we have a value of 1. The limit as x goes to 1 from the right-hand side, I'm coming down the curve towards a value of 3. Now, notice that there is an open circle at 3. So I never exactly hit 3, I'm actually approaching 3. In this situation, the limits are not the same. The left-hand limit is not the same as the right-hand limit. So I would say the limit as x goes to 1 of f of x does not exist. Let's look at a new graph. Let's first find the limit as x approaches 0. In order to do that, I have to find the limit as x approaches 0 from the left. Following my cursor, I'm getting closer to 0 from the left. And I have a value of -1/2. Now the limit as x approaches 0 from the right-hand side comes down the curve. And again, I have a value of -1/2. So since the left-hand limit is the same as the right-hand limit, I can say the limit as x approaches 0 of f of x equals -1/2. Let's take a look at the limit as x approaches 1. First, I will find the limit as x approaches 1 from the left-hand side. And I have a hole here. The value of the function is still approaching 0. I'm not exactly getting to 1 exactly. I'm just approaching the value of 1, so I'm never really jumping out of the hole. The limit as x goes to 1 from the right-hand side approaches the same hole. I'm never getting towards the hole, I'm just approaching it, so I still have the value of 0. The left-hand limit is the same as the right-hand limit. So I can say the limit as x approaches 1 of f of x equals 0. Now, if I were to ask you to evaluate the function at f of 1, the function has a value of -1. The limit, though, is 0. The function does not have to have the same value as the limit. The limit is just what is this graph approaching? Well, it's approaching 0. Once I finally get there, evaluating it at f of 1, I would jump to -1. Let's now find the limit as x approaches -2. As x approaches -2 from the left, when I'm on the graph has an asymptote, and it's going to continue up forever towards infinity. The limit as x approaches -2 from the left-hand side does not exist, we would say in parentheses, since technically you can't get to infinity. As I approach -2 from the right-hand side, you can see that I, again, I'm going towards, this time, -infinity because of the asymptote. But technically, you can't get there. I would say the limit, in parentheses, does not exist. The left-hand limit, as x approaches -2, is positive infinity. The right-hand limit, as x approaches -2, is negative infinity. These two limits are not the same. So the limit as x goes towards -2 simply does not exist, since the limits are not approaching the same value. Let's look what happens at the other asymptote, the limit as x goes towards +2. The limit as x approaches +2 from the left-hand side, the function continues up towards infinity because of the asymptote, which does not exist since you can't get there. We put this in parentheses again. The limit as x goes to 2 from the right-hand side goes towards infinity, which does not exist. So we can say the limit as x goes towards 2 is equal to infinity, which does not exist. The left-hand limit is the same as the right-hand limit, so the limit goes towards infinity, but we should probably denote that with does not exist as well, since you can't get there. In the previous example, the limit was going towards positive infinity from one direction and negative infinity from the other. So I would simply say the limit did not exist. In this example, it's a little bit different because both limits are going towards the same place. They are approaching a specific value, but since I can't get to that value, I still denote does not exist. If I asked you to evaluate the function at 0, I would say the f of 0 is equal to approximately negative 1/2. The function evaluated at negative 2 does not exist since I'm on the asymptote. The function evaluated at positive 1 equals negative 1 because of the hole. So we can see that the limits and the function do not have to have the same value. Here's the next graph that I'm going to play around with. I'm going to start out by finding the limit as x approaches 0. I'm going to have to find the limit as x approaches 0 from the left and the limit as x approaches 0 from the right. The limit as x approaches 0 from the left, following my cursor, follows along the little horizontal segment until I reach a value of negative 1. The limit as x approaches 0 from the right is on a different horizontal segment from the right, working my way towards the left. The function is approaching the value of 0. So the left-hand limit and the right-hand limit are different. I can say the limit as x approaches 0 does not exist. Next, let's find the limit as x approaches negative 2. First, finding the limit as x approaches negative 2 from the left, I'm on the small curve at the bottom left, and I'm working my way towards the right. You can see that this function is approaching the value of negative 3. The limit as x approaches negative 2 from the right is on the horizontal segment, and I am approaching the value of negative 2. The left-hand limit is different from that of the right-hand limit, so I say the limit as x approaches negative 2 does not exist. The function evaluated at negative 2 is different though. If I'm trying to find the value of the function by evaluating at f of negative 2, I'm going to jump because of the hole, and I'm going to jump down to the value of negative 3, which is on the smaller curved portion. The function evaluated at 0, the f of 0, there's a hole there. I would jump down to where the graph does exist, and I would have a value of negative 1. Notice that the function exists at negative 2 and has a value of negative 3, even though the limit does not exist. That's pretty much it for evaluating limits graphically. We will continue to evaluate limits graphically, but we will also do this by hand and with a calculator. Thanks for watching.